Suppose if you get all the truth values as t, 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 then the given compound proposition is called a tautology. Conjunction means true and true is true. In all cases it is false. True and true is true. True and true is also true. True and true is true. True and true is true. True and true is true. True and false is false. False and true is false. False and false is false. The truth values of 4th and 7th column are same. That means these two are logically equivalent. Hello dear students, welcome to this session of Discrete Mathematics of 2nd semester B.Ca. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram, 1st grade college, the Temple of Excellence. Today in this session, I am going to take the revision of a first unit, that is 2nd semester Discrete Mathematics Unit 1. So, the first unit is the Foundation Basic Structures. Foundation Basics Structure. Now, in the first unit, you are going to study regarding mathematical logic and then matrices determinants and then binomial, theorem and sets, relations and functions. Now, today let us discuss regarding mathematical logic and the binomial theorem. So, you are much familiar with the construction of the truth table for conjunction, disjunction, conditional, biconditional and the negation. Now, let me recall. For conjunction, true and true is true, remaining are all false. For disjunction, false and false is false, remaining are all true. So, in conjunction, true and true is true, true and false is false, false and true is also false, false and false is also false. Whereas in disjunction, true and true is true, true and false is true, false and true is also true, false and false is false. That is the difference between conjunction and disjunction. Now, then conditional. In case of conditional, true and false is false. In all other cases, it is true. True and true is true, true and false is false, false and true is also true, false and false is also true. Whereas in case of biconditional, true and true is true, false and false is also true, true and false is false, false and true is also false. So, in case of negation, if it is true means negation of true is false, if it is false means negation of false is true. So, these are the basic things you might have been studied. Now, based on this, let us take a problem for 5 marks. This is very important problem. So, you may expect one 5 marks question from this. So, construct the truth table for the following. So, what is the statement given? The given compound proposition is P conjunction Q conditional to P disjunction Q. P conjunction Q conditional to P disjunction Q. Let us split. So, write P, Q, then P conjunction Q, P disjunction Q. These two are connected by the conditional statement. Split. So, P, Q, P conjunction Q, P disjunction Q, then P conjunction Q conditional to P disjunction Q. As you know, the truth values for P and Q, for P it is true, true, false, false. Whereas for Q it is alternative, true, false, true, false. Right. As I told, for conjunction, true and true is true. Remaining cases it is false. True and false is false. False and true is also false. False and false is also false. This is for conjunction. Whereas for disjunction, true and true is true. True and false is also true. False and true is also true. False and false is false. Okay. Now, just write the conditional for these two. The conditional statement for these two. So, what is conditional? True and true is true. False and true is also true. False and true is also true. False and false is also true. So, this is the truth table for P conjunction Q conditional to P disjunction Q. So, here suppose if you get all the truth values as T, 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 then the given compound proposition is called a tautology. Then it is called a tautology. So, this is an example for a tautology because in the last column, all the truth values are true, 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 true. Therefore, it is a tautology. Hope you followed. So, this is a 5-marker question. Okay. Just write down P, Q, P conjunction Q, P disjunction Q and the conditional between P conjunction Q and P disjunction Q. For conjunction, true and true is true, remaining are all false. For disjunction, true and true is true, true and false is also true, false and true is also true, false and false is false. Now the conditional for these two, conditional is true and false is false. In all cases it is true. True and true is true, false and true is also true, false and true is true, false and false also true. So hence this is an example for a tautology. Now let us move on to the next one more problem. Construct the truth table for P conjunction negation Q biconditional to negation P. Split this. Write down P, Q, then negation of Q. First part P conjunction negation Q, then negation P, then P conjunction negation P biconditional to negation of P. Okay. So P, Q, negation Q, then first part P conjunction negation Q, then negation of P, and the biconditional for these two, biconditional for these two, that is P conjunction negation Q biconditional negation P. Now as usual, write down the truth values for P. This is true, true, false, false. Alternative true, false, true, false. Now negation of Q. Negation of Q, for T it is F, for F it is T, for T it is F, for F it is T. So FT is the negation. Now write the conjunction for these two. Conjunction for P and negation Q. Conjunction for these two. So in case of conjunction, true and true is true. In all cases it is false. So true and false is false. True and true is true. Again false and false is also false. False and true is also false. This is the conjunction. P conjunction negation Q. So that is conjunction between these two. True and false is false. True and true is true. False and false is false. False and true is also false. Now write down the negation of P. What is the negation of P? Negation of P, it is for true it is false. For true it is false. For false it is true. For false it is true. FFTT is the negation of Q. So FFTT. Now write down the biconditional for these two. Biconditional for P conjunction negation Q and negation of P. In case of biconditional, true and true is true, false and false also true. In other two cases it is false. So false and false is true, true and false is false, false and true is false, false and true is equal to false. So here what do you say in this? So if you get all the truth values as T, 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 then it is tautology, or all the truth values as F, 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 then it is called contradiction. If it is like this, T, F, T, T and F, then it is neither a tautology nor a contradiction. This is an example for which is neither a tautology nor a contradiction. So just write down the truth value for P, Q, negation of Q, P conjunction negation Q, then negation of P, and the biconditional for these two, false and false is true, true and false is false, false and true is also false, false and true is also false. So this is an example for neither a tautology nor a contradiction. This is also a 5-marker question. Now let us take a next 5-marker question. Show that the proposition P conditional to Q biconditional to negation P disjunction Q is a tautology. So verify whether this is a tautology or not. Now just split it. P, Q, P conditional to Q, negation P, disjunction Q, and P conditional to Q biconditional to negation P disjunction Q. Now as usual, write down the truth values. For P it is T, T, F, F, T, F, T, F. Now conditional. Conditional means true and false is false. In all cases it is true. So true and true is true. True and false is false. False and true is true. False and false is also true. This is biconditional. Now negation of P. Negation of P. For T it is F. For T it is F. For F it is T. For F it is T. F, F, T, T. Then negation of P conditional to negation P disjunction Q. Negation P and disjunction Q. So the disjunction for these two, that is negation P and Q. So in case of disjunction, false and false is false. In all cases it is true. So false and true is true. False and false is false. True and true is true. True and false is also true. So we are writing the disjunction for these two, that is negation of P and Q disjunction. Disjunction means false and false is false. In all cases, it is true. So false and true is true. False and false is false. True and true is true. True and false is also true. So negation Q, negation P under Q. Now, just write down the biconditional for these two. Biconditional for P conditional to Q, biconditional to negation P, disjunction Q. Now, in case of biconditional, both the statement true and true is true. False and false is also true. So true and true is true, false and false is also true, true and true is true, and true and true is also true. See, if you observe carefully, all the truth values in the last column are T, 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 T. So therefore, this is a tautology. So therefore, it is a tautology. The reason is because all the entries in the last column are true. So therefore, this given compound proposition is a tautology. That's it. Okay. Now move on to the next problem. Let us verify the contradiction. Show that the given proposition P conjunction Q conjunction negation P disjunction Q is a contradiction. Now same split P Q, P conjunction Q, P disjunction Q, negation of P disjunction Q and conjunction for P conjunction and negation of P disjunction Q. So the truth values are same. For P it is true, true, false, false, alternative true, false, true, false. Write down the conjunction. Conjunction means true and true is true. Remaining cases it is false, 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 false. Disjunction. False and false is false. In all cases it is true. Right. So true and true is true, true and false is true, false and true is also true, false and false is false. Now write down the negation for this. Negation of disjunction. Negation of true is false, true is false, true is false, false is true. That's all. Now just write down the conjunction for these two. Conjunction of P conjunction Q, P conjunction Q conjunction this. So the conjunction between these two. So conjunction means true and true is true. In all cases it is false. So true and false is false. False and false is also false. False and false is false. False and true is also false. See, observe carefully. All the truth values in the last column are F, 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 F. So therefore this is a contradiction. So if you get all the truth values, for the set of all combinations as false, 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 then it is called as a contradiction. So therefore it is a contradiction. This is a contradiction because all the values in the last column are F. All the values are F in the last column. Okay. Now this is how we are going to verify the tautology, contradiction, neither tautology nor contradiction. So these are all 5-marker questions. So you may expect 1 5-mark questions like this. Now let us take one 7-mark question. So you may expect 7-mark questions like this, or sometimes they may also ask De Morgan's law or distributive law. So De Morgan's law and distributive laws are very, very important. Just practice the problems based on De Morgan's law and the problems based on a distributive law. You may expect one question for the point of examination. Let me take this for 7 marks. Prove that P disjunction P conjunction R biconditional to P disjunction Q conjunction P disjunction R is a tautology. So here P, Q, R are given. So in case of P, Q and R, so for P, Q and R, this is 2 into 2 into 2. So 2 to the 4 to the 8 set of elements will get truth values. 8 set of truth values. So let us split the table. P, Q, R, then P conjunction R, then first part P disjunction P conjunction R, second part P disjunction Q, P disjunction R, and the conjunction between these two, P disjunction Q, P disjunction R, conjunction between these two. So conjunction of P disjunction Q and P disjunction R, then the biconditional, let us represent this as A and this as B, then biconditional between these two, A and B. If you get all the truth values in the last column as T, 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 then it is called a tautology. Okay, let us verify now. Now, how to write the truth values for this? So, first 4 are T, 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 right? Remaining 4, false, 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 false. Okay, first 4 T, remaining 4 false. Next 2, 2. First 2 are true, true, remain second 2 are false. Again, true, true, false, false. T, T, F, F, T, T, F, F. So first 2 are true, true, then false, false, again true, true, false, false. For R, alternative true and false. That's all. T, F, T, F, T, F, T, F. That's all. Okay. So T, 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 F, F, F. Again T, T, F, F, T, T, F, F, T, F, T, F, T, F, T, F. 8 set of truth values. Now, conjunction for a P and R. So, see, don't get confused. Conjunction for P and R. So, I will write the conjunction. Now, P conjunction R. The conjunction for a P and R. Conjunction is true and true is true. In all cases, it is false. True and true is true. True and false is false. True and true is true. True and false is false. False and true is false. False and false is false. False and true is false. False and false is also false. So, the conjunction for a P and a R. Similarly, now write down P disjunction, P conjunction R. So, for these two, write down the disjunction. So, the disjunction between first and the fourth column. So, in case of disjunction, false and false is false. In all cases, it is true. So, true and true is true. True and false is also true. True and true is also true. True and false is also true. False and false is false. 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 So, T, 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 F, 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 F. Okay. Now, write down P disjunction Q. P disjunction Q. The disjunction between P and Q. Now, write down the disjunction for P and Q. P and Q. The disjunction is nothing but false and false is false. In all cases, it is true. So, true and true is true. True and true is also true. True and false is also true. Again, true and false is also true. Again, false and true is true. False and true is also true. False and false is false. False and false is false. Okay. T, 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 T and F. Now, again, the disjunction between P and R for these two. True and true is true. Again, true and false is also true. True and true is also true. True and false is also true. False and true is also true. Again, false and false is false. Then, false and true is also true. Again, false and false is equal to false. Right. So, for P and R. Now, just then, write down the conjunction for these two. The conjunction. The conjunction for these two. The conjunction. Conjunction means true and true is true. In all cases, it is false. True and true is true. True and true is also true. True and true is true. True and true is true. True and true is true. True and false is false. False and true is false. False and false is false. Now, the final answer. Now, just write down the biconditional statement for A and B. Biconditional for these two. So, biconditional means true and false is false. In all cases, it is true. So, true and true is true. True and true is also true. True and true is true. True and true is true. Next, false and true is also true. False and false is also true. False and false is also true. False and false is also true. See, all the truth values in the last column are T, 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 T. Therefore, this is a tautology. See, here all the truth values are T, T, T. Therefore, this is a tautology. Conclude this. Therefore, it is a tautology. This is a tautology. So, hence, what is the conclusion? Therefore, the given compound proposition is a tautology. That's all. So, if you do this much, definitely you will get how much marks? 7 marks from this, right? Now, so these type of problems are very useful for doing the problems on distributive laws, right? Now, next, Let us take one more problem like logically equivalence. Logically equivalence. Now show that negation of P, yes, negation of P conjunction Q is logically equal to negation P disjunction negation Q. So let us write the table PQ, P conjunction Q, again negation of P conjunction Q, negation P, negation Q, again negation P disjunction negation Q. Now as usual the truth values for P true, true, false, false. This is true, false, true, false. Now conjunction means true and true is true. In all cases it is false. Okay, negation of this P conjunction Q, for T it is F, for F it is T and T. Right. Now negation of P, for P negation is for true F, F, for F it is T and T. Negation of Q, for T it is F, for F it is T, for T it is F, for F it is T. This is the negation. Now write down the disjunction for these two. Disjunction F and, yes, in case of disjunction false and false is false, in all cases it is true. So F and F is F, F and T is T, T and F is T, T and T is equal to T. Now let us represent this as first column, second column, third column, fourth column, fifth, sixth and seventh. Observe carefully. So fourth column, the elements, the truth values of fourth column and the truth values of seventh column are same. See, F, F, T, 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 T. What do you say? The truth values of fourth and seventh column are same. That means these two are logically equivalent. Since the truth values of fourth and seventh column are same. So the truth values of these two columns are same. Therefore they are logically equivalent. They are logically equivalent. So how to write? So therefore we can write, therefore negation of P conjunction Q is logically equivalent to negation P disjunction negation Q. This is how. So if you do this much, definitely you will get 5 marks, sometimes 7 marks for this also. Okay, very important problem. So these are few types of problems in mathematical logic, right? So you may expect one question in a converse, inverse and contrapositive, converse, inverse and a contrapositive of a conditional statement, right? Now move on to the next concept. Let us discuss regarding the binomial theorem. So before going to binomial theorem, by using binomial coefficients and the formulas based on permutations and combination, let us do some problems. Now we know the formula for the permutation. What is the formula for NPR? NPR is equal to n factorial divided by n minus r factorial, and similarly NCR is equal to n factorial divided by r factorial into n minus r factorial. Now let us recall the formulas for permutation. NPR is equal to n factorial divided by n minus r factorial, and NCR is equal to n factorial divided by r into n minus r factorial. Now these are the two problems, very important type of problems. What is given? If find n if P n2 is equal to 110 and C of n2 is equal to 45. P means permutations and C means the combination. Let us take the first one. So what is given? P of n comma 2 is equal to 110 means n P2 is equal to 110. What is the formula for NPR? NPR is equal to n factorial divided by n minus r factorial is equal to 110. What is r here? R is equal to 2. N factorial divided by n minus 2 factorial is equal to 110. Simplify this. What is the meaning of n factorial? Means n into n minus 1 into n minus 2, n minus 3, that is n minus 2 factorial divided by this n minus 2 factorial as it is equal to 110. So n minus 2 factorial gets cancelled. you will get n into n minus 1 is equal to 110. Let me simplify. So what we will get, n into n minus 1 is equal to 110. Simplify this. N into n is n square minus n minus 110 is equal to 0, a quadratic equation. So this can be factorized as 110 can be factorized as 11 into 10. 11 tens are 110. So therefore this can be written as, this is minus and plus. So n square minus 11n my plus 10n minus 110 is equal to 0. So we can group this as, we can take n common factor, n minus 11 plus 10 common factor, n minus 11 is equal to 0. So therefore the factors are n minus 11 into n plus 10 is equal to 0. So n is equal to 11 or n is equal to minus 10. We cannot take the negative value. So therefore the value of n is equal to 11. That's it. N is equal to 11. Okay. So n is equal to 11 is the required answer for this. Now if you want to verify, you can verify it. C of n comma 2 is equal to 45. That means NC2 is equal to 45. What is the formula for NCR? N factorial divided by R into n minus R factorial is equal to 45. Here also, what is R? R is equal to 2. So NC2, that is nothing but n factorial divided by R is 2 factorial into n minus 2 factorial is equal to 45. So n factorials means n into n minus 1 into n minus 2 factorial divided by 2 factorial means 2 into n minus 2 factorial is equal to 45. So this is n minus 2 factorial gets cancelled. What we have, n into n minus 1 is equal to multiplied 45 into 2, that's equal to 90. Same problem, n into n is n square minus n minus 90 is equal to 0. Factorize this 90. Minus 90 can be written as 10 into 9. 10 nines are 90. So this is minus and plus. This can be written as n square minus 10n plus 9n minus 90 is equal to 0. See, minus 10n plus 9n is minus n. These two are one group. So make this as one group. This is one group. This is another group. What is a common factor? N is a common factor. N minus 10 plus what is a common factor? 9 minus 9 tens are 90. In these two, what is the common factor? N minus 10 and n plus 9 is equal to 0. Now, n minus 10 is equal to 0 or n plus 9 is equal to 0. N is equal to minus 9, we cannot take. So, n is equal to plus 10. So, therefore, the value of n is equal to 10. So, n is equal to 10. If you put n is equal to 10, definitely you will get a 10C2 is equal to 45. That's it. If you want, you can verify. So, if you want, put n is equal to 10. So, what is 10C2? 10C2 is nothing but 10 factorial divided by 2 into 10 minus 2 is 8 factorial. So, this is 10 into 9 divided by 8 factorial gets cancelled. 2. 2 5s are 10, that is 9 5s are 45. That's it. So, the answer is correct. So, this is how we are going to solve these type of problems. Very important for the point of examination. We expect this type of questions in 5-marker questions. Okay. So, this is how we are going to solve this type of problem. Now, let me take one very important problem on binomial theorem for 7 or 8 marks. These type of problems are very important. This is an important problem for 8 marks. Sometimes they may ask for 7 or 8 marks. Expand 4a plus 3b to the power of 4 using binomial coefficients or by binomial theorem. What is given? 4a plus 3. 4a plus 3b to the power of 4. So, we know that the formula for x plus a to the power of n is x raised to n plus nc1 x to the power of n minus 1 into a plus nc2 x to the power of n minus 2 into a square plus etc. Now, comparing with this, x is equal to 4a and a is equal to 3b and n is equal to 4. Using this formula, so we can write 4a plus 3b to the power of 4, x raised to n. X raised to n means 4a to the power of n is 4 plus nc1, 4c1 into 4a to the power of x to the power of n minus 1, 4a to the power of n minus 1 into a is nothing but 3b plus 4c2, after 4c1 it is 4c2 into 4a to the power of n minus 2, 4 minus 2 into a square, that is 3b whole square. Next term, what is the next term? Plus 4c3, then after 4a to the power of 4 minus 2, you will get 4 minus 3 into 3b whole cube, nc3 into x to the power of n minus 3 into a cube, plus the last term is 4c4 into 4a to the power of 4 minus 4 into 3b whole to the power of 4. So this is very, very important. So if you substitute these values, if is in the given formula, in this formula, definitely the remaining part is the 50% of the work is finished. Now this can be written as, so we know that 4c1 is always equal to 4 and 4c4 is equal to 1. 4c1 is 4 and 4c4 is equal to 1. Find out 4c2. So 4 factorial divided by r is 2 into 2 minus 4 minus 2 is 2 factorial. This is 4 into 3 into factorial 2 divided by 2 into 1 into factorial 2. 2 gets cancelled, 2 2s gets cancelled. This is 6. 4c2 is equal to 6. And finally 4c3. What is 4c3? 4 factorial divided by 3 factorial into 4 minus 3 factorial is 1 factorial. So 4 factorial can be written as 4 into factorial 3 divided by this factorial 3 into 1. These two gets cancelled is equal to 4. That's all. Now substitute the values. So what we got? 4c1 is equal to 4. 4c2. What is 4c2? 4c2 is equal to 6. 4c3. 4c3 is equal to 4. 4c4 is equal to 1. 4c4 is equal to 1. Substitute here. So therefore, this 4a plus 3b whole to the power of 4 can be written as, so 4 to the power of 4 into a to the power of 4 plus 4c1. What is 4c1 is 4. 4 into 4a to the power of 4a to the power of 4 minus 1 is 3 into 3b. Let me write. Plus next 4c2. What is 4c2? 4c2 is equal to 6 into 4a to the power of 2 into 3b whole square. Next 4c3. What is 4c3? 4c3 is equal to 4 into 4a to the power of 4 minus 3 is 1 into 3b whole cube. And last term 4c4. What is 4c4? 4c4 is 1 into 4a to the power of 4 minus 4 is 0, 3b to the power of 4. So 1 into 4a to the power of 0 into 3b to the power of 4. Since you know a to the power of 0 is equal to 1. So therefore this can be written as 4 to the power of 4 a to the power of 4 plus 4 into, this is 4 cube a cube 3b plus this is 6 into 4 square into a square into 3 square into b square plus 4a to the power of 1, 4 to the power of 4a to the power of 1 is 4 into a into 3 cube and b cube plus, so 4a to the power of 0 is 1. This is 1 into 3 to the power of 4 b to the power of 4. So you just simplify this. So the final answer is therefore 4a plus 3b whole to the power of 4 is equal to, so if you want you can simplify 4 multiply it. So here 4 to the power of 4, 4 is a 16, 16 4 is a 64 into 4 is 256. So 256 a to the power of 4 plus here also 4 4 is a 16, 16 4 is a 64 into 4 is 256 into 3. 256 into 3. That is 768. 768 into a cube b. plus here this is 4 4s are 16, 4 4s are 16, 3 square is 3 3s are 9 into 6. This is equal to, so 16 into 9 into 6 is 864. So this can be written as 3 square is 9, 4 square is 16 into 6 is 864 times. What is left over is a square b square plus the next term. So what we have, 4 4s are 16 into 3 cube. 16 into 3 cube. 3 is a 9, 3 is a 27. What is this equal to? So 16 into 27 is equal to 432. That is 432. Okay. Now write on this. So 2 cube is, 3 cube is 3 is 9 is 27 into 16 is 432. 432 a b cube. And the last term is 1 into 1 is 1. 3 to the power of 4. 3 3s are 9, 9 3s are 27. 27 into 3 is 81 b to the power of 4. 81 b to the power of 4. So this is the expansion of 4a plus 3b whole to the power of 4 using binomial theorem or binomial coefficients. That's it. So the number of terms must be 4 plus 1, 5. See, 1, 2, 3, 4 and 5 terms. Alternatively, the value of a goes on decreasing. A power decreases. A power 4, a cube, a square, a and a constant. The value, the power of b increases. B power 0, b to the power of 1, b square, b cube and b to the power of 4. That's it. This is how we are going to solve this problem using binomial theorem. Very important for 8 marks. So definitely you will expect this type of question, right? Now, so I'll give one homework problem for you. So same type, expand x square plus 2 by x square whole to the power of 5 using binomial theorem. This is an homework problem for you. And here x is equal to x square and a is equal to 2 by x square and n is equal to 5. So just using binomial theorem, solve this, you will get the answer. That's it. Okay, hope you follow. So these type of problems are very, very important for the point of examination. Okay, that's all regarding today's session. Let us meet with a different concept in the next session. Thank you very much.